Hello, my name is Professor Rad, and today we're going to talk about some different kinds of numbers. Now, I know I have a lot of writing on the board behind me. Feel free to ignore that for right now. And then when we start talking about it, I'll give you a chance to pause the video and copy down anything that you want for a notebook. But I wanted to start out by talking about language and numbers and how I find those things fascinating. So I think it's really interesting how the way we talk about numbers impacts the way that we think about numbers. So for example, you might have seen numbers like this before with the X's and I's and V's and things. So this is how the ancient Romans used to write numbers. So these are Roman numerals. For them, an X represented 10, the I meant 1, and the V meant 5. So this number here is 24 because you have 10 and 10, that makes 20. And then you have 1 before 5. So the first number before 5 is 4. So that would give you 24. If this one was after the V, then you'd have 26 because that would be 1 after 5. So I just think that that's really interesting. The way that French say numbers is also really interesting to me. So I took French in high school, and so I learned how to say numbers like 80. So 80 in French is 80. So 4 means 4, and 20 means 20. So 80. 4 times 20 will give you 80. If you want to say something like 97, then it's 97, which is 4 times 20 plus 10 plus 7. So there's a lot of math built into how the French say numbers. So the way that they think about numbers like 80 or 97 is different from the way that native English speakers might think about those numbers, because we don't have a language like that. Instead, we have our language is really based on tens, right? So you have your numbers 0 through 9, and then you have 10. And then you basically have 10, 1, 10, 2, 10, 3, right? 10 kind of sounds like teen, hence 13, 3 teen, 3, 10, right? So 3 and 10, 4 and 10 is 14, 5 and 10 is 15, and so on. And then you get to 20, and then you have 21, 22, 23, up to 29. And then you have 30, 31, 32, 33, up to 39. 40, 41, up and so on, right? So the English language is really kind of based on this. Like once we get to 10, you chunk it and you move on, right? So 10 becomes very important in the English language. 10 is also really important to Arabic numerals. So these numbers that we use, these are called Arabic numerals. And they are based off of numbers with 10, because there are 10 symbols, 0 through 9, because we have 10 fingers. And so that's why humans evolved to think about numbers in terms of tens. If we had 8 fingers on each hand, then we might have evolved so that 8 was nice, like 10 is nice for us. So that's just kind of interesting to think about. Like that's legit why people think we have 10 symbols, because we have 10 fingers. There are some ancient number systems that use 5 as a base and others that use 2. So anyway, I could ramble about that forever. I'm not going to. So, but that's kind of what I think about when I think about numbers. So we're going to look at 2 different lists of numbers here. So this is where I'm going to move aside if you want to pause the video. And oh, I meant to dim my screen so it didn't reflect for you. There you go. So if you want to pause the video here and copy down these definitions, you can do so, and then we'll talk about them. All right, so you might not have known how to write these. So you might have been like, oh, do I have to write those down? Yes, so these, I wrote them over here. These are called braces. So I'm gonna write that underneath. These are called braces. Or sometimes I'll call them curly brackets. So one way that you can do them is to do like a parentheses with a nose. That's one way some folks do it. Honestly, I mean, had a lot of practice, so I'm used to writing them. If you just want to do like a squiggle, that's okay too, because that's how a lot of mathematicians will write it. It's just a little squiggly on the board. So we're going to be using braces, and we use the braces to surround collections of numbers. Okay, so that's a notational thing. That's a way that when a mathematician is looking at something written down, they know that that's for kind of enclosing a collection of things. So we have a set of natural numbers. The reason they're called natural numbers is because they're the numbers we naturally start counting with. So when you first learn how to count, you've got 1, 2, 3, 4, and so on. So those are natural numbers. Any number that you would say when you're counting is going to be a natural number. Now this ... here, this is an ellipsis. So the ... is an ellipsis, if you wanted to know the phrase for that. And that just means this list is going to continue forever. So in our last video, we talked about inductive reasoning, meaning patterns that continue. So the ellipsis is saying that this pattern is going to continue forever. So a number like 28 is going to be a natural number because it's included in this list. If we're counting, we would count to 28. A number like 2.5, however, is not in this list because we go directly from 2 to 3. So like those mixed numbers or fractions or decimals that have like little pieces or components to them are not in our natural numbers list. The whole numbers are very similar to the natural numbers because the whole numbers include the naturals, but they also toss in 0. So the whole numbers start at 0 and then move to 1, 2, 3, 4, 5, and so on. So there's only one number that's a whole number that isn't a natural number, and that is 0. Any other number like 56, 56 is a natural number, and 56 is also a whole number. So it's really important. In our last video, I mentioned that math looks at collections of objects and then interacts them. So when we want to define the objects we're interacting, we're going to call them by the set they belong to. So if I were to say, we're going to define this for natural numbers, that means just these numbers here. 0 is not included in that definition. If I say we're going to define this for whole numbers, now I am including 0 in that definition. So that's why these groups of objects are going to be important. They tell us what types of numbers we're working with and are allowed to interact. And then our third definition here is to indicate the types of sets that these are. So a set is infinite if the list of numbers goes on forever, or if you can't make a list out of them. Like all the decimals, we can't make a list of all the decimals in order. That was actually a really hard math problem that took mathematicians a really long time to establish. And there's still questions about infinity that we haven't answered. So infinity gets kind of strange. So already some heavy concepts, but we're just learning the terms here. And if a set's not infinite, then it's going to be finite. So if I were to have a set of just like 3 numbers, like 1, 2, and 3, this would be a finite set because it ends. There are no ellipses afterwards showing that the list continues. Whereas up here, we have this ... that's showing that that list of numbers is going to continue forever. So these are the types of objects that we're going to be looking at. We're going to be looking at natural numbers and whole numbers to begin with, and then we'll throw the decimals in a little bit later. So in the next video, we'll be looking at whole numbers and saying, how do I like write really the names of like really big numbers, right? So we have 5 or 3, but what if I have like 1, 2, 3, 7, 9, 0, 6, 8, 5, 4, 2, 5, 9. What number is that? How do I actually say the name of that number? So that's what we'll look at in the next video. We'll talk about place value and why that's important. And yeah, so I'll see you then. In the meantime, I hope you have a wonderful day. Bye for now.